So we're at the whiteboard of knowledge, and I want to explain the two different circuits, the air horn solenoid circuit and then the compressor circuit separate. So let me zoom you in over here. Let me try to fix this a little bit. Get us in a little tighter so we can see this side, and then we'll go to the other side. So what's going on here, it's fairly simple. Obviously, to complete a circuit, we have to have positive and negative, right? So our battery has a ground, and as you see that right there, and then you saw we have that inline 5 amp fuse, and we want the fuse as close to the battery as possible. Now this solenoid at the horn, here's our horns down here and our switch, it's not going to draw much amperage like I mentioned, so we're not worried about having a big amp fuse in there. We don't need it. Anyway, the power flows through the 12 volts through this. It was I believe it was 18 gauge wire, and we have our switch you saw inside the dash. Now I drew the circle because we had that momentary switch just so it's on when you push it in, and when you let go it pops. And it basically, I have the switch right now is on and the horn would be blasting. I did let me mention right here, so we have the air line that comes in here, okay, that's that like 3/4, whatever it was, air line. There's constant air pressure as long as the compressor is filled up, right? Sitting here, it's actually goes into the solenoid, and when that solenoid opens, it's allowing air to flow into the actual horns themselves, right? So that's how that's working. Now that's when it's on. When it's off, this is closed, air cannot get through here. So technically, the compressor's not running, none of that. As long as there's some air pressure behind here, these will blow if the solenoid opens. And the way it opens is turning this on. The continuity flows through the switch. Now, this could have been red right here. It does not matter at the solenoid which side is power and which side's ground, as long as there's power and ground. So that's our ground. And I just smeared that a little bit. But anyhow, it's that simple. Now this would be called power side switched. We could easily just take the power lines, connect them together, just have one right to the solenoid, take this switch and put it, I kind of drew it in here a little bit, in line with the ground side. So if we cut the ground off, the solenoid, it's not going to work. Like I said, you have to have that complete circuit. Ground is very important. So you could ground side switch it or power side switch it. In this case, we just power side switched it. It was just the way we ran the wires. It was just easier to do that way. No relay. That's just how it is. So keep in mind, basically all that's doing is open and closing a valve to allow the air to flow or not flow. So let's take a look now at the compressor circuit side of things. So where we have a relay, our power distribution box, here's our compressor with the pressure switch, our air tank and our battery. So it's pretty basic when you just look at it on a diagram like this, and it'll help you so you can wire it up properly. But what we start off with here is our battery. So basically, we just have our standard ground, our negative cables there. Here's our battery positive, 12 volts. Now, I mentioned the compressor draws, I think it pulls like 19 amps, and on spike, it's probably closer to 25 or 30. So we have an inline 35 amp with a 10 gauge wire. And just so you know, anytime you put an inline fuse in, no matter what you're working on, you want it as close to the power source as possible. That way, if there's a short, this fuse blows, you don't have, if the wire was to be damaged, it's minimal, okay? So it will basically blow, cut the power off, and whatever's working won't be working, and hopefully okay. And you'll have to find out the reason for, the fuse blowing. But our 10 gauge wire flows to our relay. Now the relay is a standard 4-pin, and it's always labeled 30. You'll have 86, 87, and 85. Now something to consider is it's usually printed on there. Yours might not be laid out like this, so just look at those numbers, or they're molded into the back. You'll see that. So your power's coming in at 30, and what we need to know or look into is our compressor. Let's just go there, okay? Because the power comes in, it's got to go somewhere. It would go out to 87, and I'll tell you in a minute how it does that. It just doesn't keep flowing, not the way we did it with the relay and this ignition source. But anyhow, our compressor has a positive and a negative. Now, by the way, this one will be red and one will be black, which will be your ground. That ground is, I tied it into number 85 here. This is also a 10 gauge wire. So this is pulling a lot of amperage. A lot of people don't think about ground when they should. The ground is just as important as the power, okay? And that 10 gauge, I actually spliced these together and we hooked that up. You saw that in the left rear at the back bumper. That's where they tied in. So there's your grounds for that. Now the relay, how that's working, over here in the power distribution box inside the cab, we had a 7.5 amp spare fuse that we tapped into with the fuse buddy. By the way, that's called that type of fuse is newer technology. It's called a micro 3. I drew a little diagram right here. You're used to just like the fuses just with 2 terminals like that, and you push that in. Well, these have actually 3, and there's 2 fuses in there. So it's like basically 2 circuits in one fuse. That doesn't matter in this case. We're not worried about that. What we needed to do is get that ignition power. But what I do want to say is it's very important that you do not go up in that circuit. Like this is rated at 7.5 amps. We wouldn't want to put a 15, 20 amp. That would start, the circuit isn't designed for that, is my point. So we only need a 5 amp fuse in there because it's just to power basically this little pressure switch, which is just a little tiny contact in there, and a relay. That's it. It's not going to draw much amperage. So we tapped into that, and I liked it because it was the ignition on power. So that power inline fuse, again, it's right there at the box, comes down and goes into one side of the pressure switch. So the pressure switch is mounted into the tank here, and it's monitoring how much pressure there is. So it's made to turn on and turn off, basically under pressure. So the compressor's job is just to make the pressure, the air pressure in there, and this sensor is to monitor it. So when it gets down to a threshold, I think it's like 110 psi, the pressure switch will close, send the power up here to the relay. Now, when it senses the power, I think in this case, this unit went to, I think it's like 160 psi or somewhere around there. It's told to shut off, saying there's enough pressure in the tank. So it'll open so that this doesn't continue to work. And I'm going to go over that in just a second here. I wanted to let you know that there's 2 leads here and two terminals. It does not matter which side the power comes in. Okay, that's another thing people get confused about. What goes where? Don't worry about it. They're both hot. They're both 12 volts here. Just connect them in. Take the other terminal. So one's coming in from the fuse, from the power box. The other one goes out here to number 86. So now 86 needs a ground. It's going to get it from 85. Basically, all this stuff is grounded off this 85. So when the pressure switch says, hey, I need air, so the compressor can turn on, it sends power here. The contact, the little contact in there closes, and it's going to allow the power to flow through to 87. Now, we know this is already grounded, so it's going to complete our circuit. You got to have that full circuit, right? And the compressor will run. The compressor will not shut off until the pressure switch says, hey, I got enough, shuts this off, opens or whatever it's going to do, and then boom, the relay contacts open, and the compressor shuts off. Bingo, it's a beautiful thing. So basically, that's how that works in a nutshell. I hope this clarifies, your install if you're doing this, or maybe you just want to learn in general about how it works. There's plenty of stuff out there as far as educational material to learn this. This is the basics, and if you know this, you can do quite a lot. You can wire in fog lamps and all kinds of Mickey Mouse stuff that you want to blow and light up and everything else. So that's it. So this is a relay. We use the relay here because of the high amperage, the draw. We don't want to send power directly there, first of all, because this thing could run. Let's say there was you had the, I didn't show it here on the drawing, but there was that air line, right? That big, that like 3/4 inch or whatever air line coming out. Say this got a leak in it, a crack or something, you weren't around the vehicle, wasn't running or anything, and the truck wasn't running. Well, if you don't have this relay built into an ignition, powered by an ignition source that comes on with the key, then the compressor is just going to fire up. the pressure switch is going to say, hey, I'm low. And regardless if anybody's around, it would just run if you bypassed all this. So you could, if you wanted to, bypass that and just run it hot, basically. I don't suggest it. This is the best way to do it. The relay prevents that excessive amperage that it cause heat to, you know, melt wiring and stuff like that, like the switch or whatever, if there's an overload. It's just a safer, it's the smart way, it's the professional way basically to go. So that's the installation. We didn't get our hands too dirty in this video, but we definitely did when we were climbing around under there. It's January right now, so it's February. We did this in January about a week or two ago, and it was kind of cold even in the garage. So be prepared for that. If you're going to lay on your back, there's a lot of, you know, back and forth and crimping and cutting. The electrical is probably the most difficult part of this whole thing. Depending where you mount the horn and your compressor, obviously you're going to have to run wire to those areas, and it might make it a little more challenging. I think where you wanted the horns and stuff was, it's cool having the horn up front instead of in the back.
Sure.
So when you go around blasting people, you know, they're not expecting it either way, but it's, you know, it's right there.
It's where you expect it to be, and it's nice how it hides right behind that bumper in the front of the Ford.
Yeah, it's real, you know, real nice and neat. Mm-hmm. And make sure that you know, when you're running that wiring, that you protect the wire. You don't want to just expose it, and you don't want fireworks happening in your truck. So, and short circuit, obviously, it's not going to work. But I think the best way to do it is the way we did it here, because the compressor will only turn on when the truck is running. Basically, it won't drain your battery. And that's the thing. So if that thing's running, you're not there, it'll kill your battery.
Sure.
And then you wake up and come out to a dead battery, or it'll wake you up in the middle of the night as it's like fouling away. Now, it's not too loud though. But anyway, anything else you want to add as far as the installation?
As far as the install went, it was a good time. We enjoyed doing the install. It took us, we broke it up in a couple of sessions. So, you know, give yourself some time, enjoy the process.
And get ready to blast. Think of all the fun you're going to have with it. So, yeah, absolutely, I agree. It's definitely not a 2.5 hour job. I think even if you wanted to mount this underneath the bed of your truck, you're going to have to make up a bracket. I don't know if they have that accessory or not, or because
on their website they do have a spare tire delete.
Okay, so
kit.
That would help. Otherwise, if you're handy, or you know you're a machinist or whatever, it'd be no problem to make up a bracket to support it there. Now, I don't know if I mentioned it, but that compressor, the air tank, has those rubber bushings underneath. So we drilled 4 holes, and then the bushings actually absorb some of the vibration and noise of that thing running.
Does a great job inside the cab. It's nice and quiet. You can't even hear it running while the engine's idling.
Okay, so other than that, I think that's about wraps it up. Leave your comments and questions down below. If you haven't subscribed yet, please do so. Check out some of my repair videos where I actually do get my hands dirty. And that's about it. So I'll see you guys on the next one. Thank you, Scott, for joining in here. He's not camera shy, as you can tell with his good looks. And we'll see you on the next one. Take it easy. Let's give it a little test when we get on the ramp. We'll see the inside cabin with the windows up.
And then we got some
Go ahead.
construction
Go for
vehicles.
it. Not too bad with the windows up.
Put the windows up.
Hit it. Yeah, that's a little louder.